Let's talk about a force that we're very familiar with, that of gravity. We've worked on a lot of free fall problems and projectile motion problems up to this point, so gravity is a very familiar force. It's also a constant force, at least around the surface of the Earth. And it changes motion, of course, because it's an unbalanced force in time. So if I drop this marker, the object accelerates to the ground. But right now, this marker has zero kinetic energy with respect to me. It has no speed with respect to me. If I let it go, it gets faster and faster as it falls. Work is being done on the marker because its kinetic energy is changing. What force does work? Well, it's the force of gravity. And gravity actually acts downward at all times, but it has different effects on the marker depending on the marker's motion. If the marker flies up, as you can see going up and then down, the marker slows as it ascends and speeds up as it descends. So let's look at the work done on a marker or any object that's tossed up or released. So if you throw an object into the air, its initial kinetic energy is 1/2 the mass of the object times the speed of the object squared. So whatever the launch speed is of this marker, that's its initial kinetic energy. The kinetic energy, as this marker ascends and slows and stops, at the very top of this the ascension of the marker, at the peak of its height, its kinetic energy is for a brief moment 0. Kinetic energy can never be negative. That's an important feature as well. Kinetic energy, 1/2 is never negative. The mass of an object can't be negative, and the speed is squared. So it doesn't matter if the speed, if you come up with a negative speed. Speed is the magnitude of the velocity, so speed should never be negative anyway. But we're squaring that term, so kinetic energy always has to be positive. As the upward speed slows due to gravity, gravity is doing work on this object as it ascends, right? So we throw it up with some initial velocity vi, it goes through some displacement d, the force of gravity is acting downward. So during the initial ascent of this marker, as it goes up, the force of gravity and the displacement are actually in opposite directions. The displacement is upwards, the force of gravity is downwards. So let's look at the work done. Work is F times d times cosine of the angle between those two vectors. Force is the force of gravity, so that's m times g, right, the weight of the object. Displacement d is still d. The angle between the objects, well, f sub g is pointing down, d is pointing up. So there's a 180 degrees between these two objects. Cosine of 180 degrees is -1, so a negative sign comes out. So the work done is the mass of the object times g, the acceleration due to gravity, times d, the size of the displacement. This is ascending. When the object is descending, the displacement is downward and the force of gravity is downward. You get the same result except the angle is 0 instead of 180, so the negative sign goes away. So the work done by gravity for a descending object is positive. The object speeds up. As work is positive, the kinetic energy of an object increases. When an object ascends, its kinetic energy is decreasing, therefore negative work is being done on the object. The object is slowing. So work can be positive or negative. Positive work increases the kinetic energy of an object. Negative work decreases the kinetic energy of an object. So an object is slowing down, negative work is being done on it. If an object is speeding up, positive work is being done on it. Your book doesn't use D, though, for this displacement. What your book uses for gravitational potential energy, actually, pause for a moment. So this is the work done on the object. How does that compare to where does that energy go, right? Kinetic energy is changing. The object slows as it ascends and increases speed as it descends. Where does that energy go? It goes into what we call the gravitational potential energy, and we'll talk about that in just a moment. Potential energy can be thought of as the ability to do work, or stored energy, like a battery, if you will. Battery is chemical potential energy. Gravitational potential energy is the ability to do work by storing energy by removing an object further up out of Earth's gravitational field. Because when you release that object, it will fall. How much energy is stored depends on a few things. It depends on the mass of the object. It's harder to lift a larger mass object, and as it falls, it releases more energy. The acceleration due to Earth's gravity, 9.8 meters per second squared here on Earth's surface. G is important because, of course, it's gravitational potential energy. G is the magnitude of the acceleration of gravity. If we were weightless, then there is no gravitational potential energy. And H, the height the object is lifted. Now, only vertical displacement measures for gravitational potential energy, which means that if you, for example, have an incline and you roll a barrel up an incline that has a total height of h, or if you just lift the barrel directly a height of h, the same amount of gravitational potential energy is stored. So the work done in both cases is the same. But now we can use this to cheat a little bit, right? Work is force times distance. So you can either apply a large force over a smaller distance to get the same result, or apply a smaller force over a larger distance, but the end result is still the same. If you've ever used a jack or a hydraulic jack, then you've used this principle, where to lift a car up a few inches, you have to pump on one side quite often, go through a lot of distance, a small force, to get a large force over a small distance. The work done for both is the same and allows us to, use a rod, a pry bar, and so on. You can use, if you ever think of a pry bar, you're going over a large distance with a little force, and the other end of the pry bar moves a little bit, but applies a much greater force on the other end. The amount of work done is the same. So gravitational potential energy is only one type of potential energy. We'll deal with others in a moment. But it depends upon, again, the mass of the object, gravitational acceleration due to that object, and the height where that object is lifted. So when you lift an object in the air, you are doing work on that object. And then when you let it go, the stored energy you've placed in that object through Earth's gravity is released into kinetic energy, and that object falls.